Hey everybody, it's Mr. Brooks, and this is called the parent functions activity. And so with parent functions, what that means is there's basically different shapes of functions, or there's different equations that make functions of different shapes. And we're going to name these. We're going to give a name to the different types of functions there are, and then we're going to call those parent functions. Down the line, what we're going to do is we're going to take parent functions and we're going to make transformations off of them. So if you say, okay, we transformed the function, you really want to know, like, what did it start? What did it look like at the beginning, right? Well, that's the parent function. The parent function is the basic function, and each of these basic functions have a different shape. So this is an exploration on how to do it. And you could just look it up or graph it in Desmos, but I think that there's a really important, um, like, you need to have the number sense, the algebraic reasoning sense as to why the shape is that way. And so in this, I want you to actually do the XY chart. So you're going to plug in X and then, see what happens when you get Y, and then graph that on paper to see the shape. Okay, because it's one thing to type in the function into Desmos and say, oh yeah, that's what it is. But really, what you also want to do is at least get an understanding of why it is that shape. Okay, and then after you understand the why, then of course in the future you'll just go to Desmos and do it lickety split because you have an understanding of it, right? So I'm going to use a metaphor here. Once you buy a car, you can always put the key in and drive it. But it is important to understand why the car drives so that if something were to break in the car, you could have an understanding of diagnosing it and fixing it. Okay. All right. So this is it. And I give you the name. So this is the equation down the first column. And then there's a coordinate plane to graph down the second column. And the name, I give you the name of the third column. And then there's the XY table in the fourth column. So you guys are going to uh, fill in the XY. Okay. All right. So I'm going to get my pen out, and -2. Linear is really easy. If you were to plug in -2 right here, what would this be? So if this was -2, this would be, oh, oh, look at me. I already screwed up. Clear selection. If it were f of -2, the answer would just be just the same thing. So it would be -2. So it would be -2. And then if you plug in -1, you get -1, and then 0, and et cetera, et cetera, et cetera. So this X goes in the input. It goes right here in the input. And then you would, of course, throw it in right there. And then that would tell you what it equals. So this is also kind of your answer, right? So you'd say f of -2 equals, and then just x, and then that would be your answer. If that sounds like it's going in a circle, it kind of is with this, and you'll see why. Like, oh, what does that mean, or why? So let's say the point -2, -2. So x is -2, y is -2. So you go -2 on the x, and then you go down to, remember, x is domain left and right, y is range up and down. So -2, -2, -1, -1, 0, 0, and you should see like, hey, this is going like a line. And in fact, it is called linear. Okay? So that would be like that example. Now let's see what else. For quadratic, it would be a little bit more involved. It's always a little bit more involved, right? So for -2, we say f of -2 is equal to -2 squared. Okay, all right. So what is -2 squared? Well, negative 2 times negative 2 is positive 4. So negative 2, 4. Negative 2, positive 1, 2, 3, 4. So you'll see that already looks different than our last one, the linear. So it has to be a different shape. So the quadratic is going to look different than the linear, and the cubic will look different than the quadratic, okay? So that's what you're going to do. You're going to fill in this XY table, and then you're going to graph this. And then in class, we're going to talk about your noticings and wonderings about it, okay?